Today's lesson is how to use partial products to multiply. Now you've already learned through other strategies and other models that a partial product is part of the product, and usually we add up those partial products together to get our final answer. Well, this model only uses partial products, and it's very, very close to the traditional algorithm, so it's the next step. Let's say that at the Super Bowl of reading final Super Bowl party, all 124 fifth graders were invited. Let's also say that we were putting together some snack packs, and in each bag of goodies, we wanted to make sure that every student had 25 M&Ms. So the question is, when I go out shopping, how many M&Ms do I need to make sure that I have in order to fairly distribute them in groups of 25 to all 124 fifth grade students? So this is a multiplication problem that can be written like this. And now we're ready to start solving. Right away, you should notice that this problem here is set up very much like the traditional algorithm or the traditional method of solving a multiplication problem. Let's see how partial products can be really useful to keep track of place value in this. Since place value is so important, and that's why we always teach it at the beginning of the year, I have drawn a hundreds, tens, and ones label for those different places. Make sure that you draw that in your notes as well. It's really important that we remember that this right here, it's not just a 1, it's a 100. And this right here, it's not a 2, it's 2 tens, which would be 20. This right here is also 2 tens, which would be 20. So we wouldn't just say, if we were multiplying, like 4 times 5 and then 5 times 2. No, it's not a 2. It's 2 tens, which is 20. So it's really important for us to do that. So we're going to take notes on this the long way first, and then you'll never have to do it again. Bear with me here. Write all of this down. Basically what we are doing is we are distributing one digit to the next. So it doesn't really matter where you start with, as long as each digit of the students gets distributed to each digit of the M&Ms. And that can be kind of tricky to keep track of. So I like to work either from top to bottom, left to right, or from bottom to top, right to left. I'm going to encourage you to start with the bottom right digit, because that is how the traditional algorithm is going to work. That way you'll already know kind of the system and the order, and you won't have to relearn something all over again. That can be especially helpful when you are multiplying with decimals, which we will get to later. So first things first, let's distribute the 5 to the 4. Then we can distribute the 5 to the, not a 2, the 20, and then we can distribute the 5 to the, don't say 1, to the 100. So check it out. Here are our steps. We'll just list them down in order from top to bottom and solve one at a time. So first, let's solve our 5 times 4 right here. 5 times 4 is 20, so I'll put a 2 in my tens place and a 0 in my ones place. Next, I've got my 5 times 20 right here. So I'll put my answer over here. Hey, these are nice friendly numbers, aren't they? That's why working with partial products can be so nice. So 5 times 20 is 100, so I'll put a 1 in the hundreds place, 0 tens, and 0 ones. And last but not least in this step, I have my 5 times 100. The power of 100. It's 500. So we can see where all of these partial products came from when we distributed. Okay, next we need to move on and take care of this 2 over here, which we know is not actually a 2 but a 20. So let's take care of it now. We now need to distribute this 20 to the 4, the 2 in the tens place, which is another 20, and the 1 in the hundreds place, which is a 1. So we've got 3 more steps to do. And here they are listed out. First, the 20 times 4, then the 20 times 20, and then the 20 times 100. As I've said before, it doesn't matter which order you distribute in because of our lovely commutative property of addition. We're going to add them up anyway. But you've got to have a system for remembering which steps you've done. So that's why I like to work like this. All right, let's figure out what these partial products are. First, let's do 20 times 4. Well, 2 times 4 is 8, and then I'm multiplying by a power of 10, so I need to place 1 0. So that would mean it's 80. Next, 20 times 20. Well, 2 times 2 is 4, and I have 1, 2 zeros in my factors that I need to place. So 4 with 2 zeros placed after it would be 400. And last but not least, we're really going to have to keep track of zeros here. 20 times 100. That's this step right here, 20 times 100. 2 times 1 is 2, and then I've got 1, 2, 3 zeros to place after it. At this point, I'm going to find it more helpful and more accurate to place the zeros first. 1, 2, 3 zeros, and then my fast fact was 2 times 1, which is a 2. I'm in my thousands place, which means I need a comma. Okay, at this point, now we can add up these partial products, which should be fairly friendly and natural to do because look at all of these nice landmark numbers. When you add them up, you should get this answer. 3,100. You can see where I carried an extra group over there. So those weren't part, these little ones weren't part of the partial products, but in adding them up, we ended up needing to regroup over to the next place value. So what does that mean for our real life problem of M&Ms? Mrs. T needs to make sure she buys at least 3,100 M&Ms. Okay, if you didn't color code your last multiplication problem, I strongly encourage you to use colored pencils or pens at home and color code this next one. It's really helpful to see where all of these numbers are coming from. And it's helpful for your parents to see that as well. Another thing that you really need to make sure that you're doing is you're keeping your columns straight because place value is so super important. If you get off from the left or the right just by one column or one place, your whole answer is going to be totally messed up. So make sure that you are working very, very neatly and keeping those columns straight for the place value. In 8th grade and also in high school, the We the People, the citizen in the Constitution, congressional hearings are actually a competition, and students can go to state and then even to nationals. But as you can imagine, it would probably end up costing some money to pay for the bus and the airfare if they're going all the way to Washington, D.C. So, let's say that a team of 18 very bright and very lucky students got to be on the We the People state team representing Idaho, getting to go to nationals. But with all of the expenses of the trip, including hotel and airfare and bus and of course some sightseeing in Washington, D.C., it's going to cost $1,029 per student. Well, obviously that's a huge financial burden for these families, so the school decides to hold a fundraiser. How much money do they need to raise to send these 18 students to Washington, D.C. for We the People Nationals? Because of our commutative property, or our flip-flop prop, we can switch the order of the factors and have confidence that we're still going to get the same answer, the same product in the end. Because of the way that the traditional algorithm is set up, I usually set up the factor that has the most digits, which in this case would be the 1029. Usually put that one on the top. It just, for some reason, looks nicer. And it's the way that you will usually see it as well, but you don't have to. Okay, I'm going to be writing place value labels as well as the side problems off to the side in parentheses. You may write that as well, but you do not have to this time. So here we go. Let's get a system. First, let's distribute the 8 to the 9, the 8 to the 20, the 8 to the 0, and the 8 to the 1000. So here they are. Now, right away you might look at this one and just say, really? Do we need to have a line for 8 times 0? It's just going to be 0. So that means we're going to be, when we add it all up, we're going to be adding 0. No. In fact, you do not need to have it there. You can skip that one because it's 0. Okay, so you figure out the partial products for each one of these, keep track of your columns, and then you can check and see if you did it right. Press pause now. Okay, 8 times 9 is 72. 8 times 20, well, 8 times 2 is 16, and place a 0. So that means 160. And then 8 times 1,000 would be 8,000. I really want to keep these columns straight, so I'm going to build my 3 zeros and then a 1. And I want to make sure that that's lined up with my thousands place right here. Next, we need to distribute the 1 to the 9, the 20, the 0, and the 1,000. So here are those steps that we're going to do. And again, here's that 0. Do we even need it there? No, we really, really don't. Woohoo! And just in the nick of time, I caught a mistake. Check it out. Look what I did. I only placed 2 zeros there. The value of this 1, it's not 100. What is it? It's a 1 in the thousands place. I need another 0 there. Let me fix that real quick. All better. See, even I have to keep reminding myself how important it is to keep track of those zeros and keep track of that place value. And now you can see firsthand how big of a difference that can make. Wow. All right. So now we have 3 more steps because we decided we don't really need to do that one. You figure out those partial products and come back and check with me in a second. Press pause now. Okay, so 10 times 9 is 90. 10 times 20, I better really keep track of these zeros. We've got 1, 2 zeros. I am going to put those in right now before I muddle it. And now I've got my fast fact. 1 times 2 is 2. 10 times 20 is 200. Okay, now I have 10 times 1,000. I better really keep track of these zeros. 1, 2, 3, 4 zeros. I'm going to put them in right now before I mess it up. 1, 2, 3, and 4. And now my fast fact is just the 1 times 1 and another 1. Wow, look at that. I got all the way over to the 10,000s place. I need to now add up these partial products. Why don't you give that a shot and check back with me to see if you got your math correct. You've done all the hardest part. Work carefully when you go to add these up. Press pause now. And hopefully you were very careful and you got 11,522. That means that the total cost of all the students' expenses on this trip would be $11,522 that they need to fundraise in order to cover these student expenses. Wow, that's a lot of dough. You have 3 options for your task tonight, depending on how much of a challenge you want. If you choose challenge A, you will be coming up with a 2-digit times 2-digit multiplication problem. For example, 36 times 84. But don't do that one. Come up with your own. If you choose option B, you will be coming up with a 4-digit times a 2-digit problem. For example, 9,251 times 31. But don't use that one. Come up with your own. If you choose option C, you will be coming up with a 3-digit times 3-digit multiplication problem, like 584 times 639. But please come up with your own problem. After you've decided which challenge you want, write a story problem using those numbers on a separate piece of paper. And yes, it has to be reasonable. It has to be able to occur here on Earth in our lives. The next thing you need to do is you need to solve your problem with a calculator and write your answer in a secret place. Do not write it on the same piece of paper that you write your story problem on, because tomorrow you're going to trade your story problem papers with someone else. That means you are going to be solving someone else's story problem when you get their paper, and someone else is going to be solving your story problem. So write neatly. Tomorrow, you'll be able to check each other's work and see if you came up with the correct answer. Have fun writing these story problems, and we'll see you in class.